What is up, most distinguished patrons of this channel? Today we are going to be going in depth on how to add filler rod while TIG welding, because this is a very significant factor in your ability to actually make decent TIG welds. So let's get into it. So anyone that's tried to TIG weld has realized that adding filler material is a little bit harder than you probably would think at first. And well, if you're used to stick welding where you strike an arc and globs of metal more or less transfer over for you and you don't have to use your other hand to deposit metal, well, stick in a lot of cases is actually easier than TIG. Same thing with MIG. MIG uses basically the same wire as this, just feeds it for you, and all you need to focus on is moving smoothly, not adding filler. Well, TIG puts the magic of adding filler, aka depositing a weld, solely in your hands and your ability, which means that you can add more or less filler to make a bigger or smaller weld, all on the fly, which is something you can't really do other than changing your travel speed with most other welding processes. Now, I'm not going to sugarcoat it here, guys, because I'm not someone who BS's. You must learn how to feed filler to where you don't have to think about it. I mean, don't get me wrong, I'm going to teach you a ton of tricks to up your welds at the start of learning TIG to where you can get decent results faster, but nothing will replace simple practice. So that's the first thing I'm going to talk about. When adding filler metal, the perfect world says you hold it in your non-dominant hand, which in my case I'm right-handed, therefore it's my left hand, and I feed it in simply by moving my fingers. Now, that's a gross oversimplification to the process, and what you're going to find is that you might watch how I'm going to tell you how to do this, and then you might find it doesn't quite work for you, and you're going to have to find a little bit of a tweak on my method, and that's fine. What matters is that you can run a longer weld without having to stop, cut the arc out, and then change the filler in your hand. That is what you need to learn. A lot of people have oddball ways of feeding the rod, and I'm going to tell you right now, the book answer is just like you see here, where I'm just slowly feeding it, right? But guess what? That isn't going to work when you hit an inside corner where there's a plate here as well, and you can't feed it because the TIG cup or the torch is in the way. You might have to feed it like this, where you come in and you come in through the top. There's all sorts of real world examples that standard feeding methods don't work. And that's why you need to, with practice, over time, develop that skill. When it comes to actually feeding the filler, it's not as hard as it looks, but it becomes difficult once the arc is lit, and that's very common. So expect when you actually are welding that all of a sudden this doesn't work, and that's why you need to do enough to where you're well practiced. But I tend to hold it between my thumb and my index finger, and then I rest the rod on my middle finger. And what I do is I very loosely, now look how loose this is, it's almost falling out of my hand. I slowly bring my fingers forward, and then I press down with my thumb, and then I slide my fingers back. By pressing down lightly, it gives me the ability to hold the rod where it is and slide my fingers. See how that works? And I can feed it. What happens is a lot of people get the death grip where they're like this, and you can't feed anything when you're holding stuff too tight, so you must relax. The more relaxed you are, the easier it is to feed the filler. And keep in mind, my skin is pretty grimy right now, so it's sticking to this rod better. If you get a good set of gloves, it should slide on it decently. And by the way, unless you have some kind of weird disability where you can't operate your fingers, stay away from those rod feeders with the wheels on them. Those are only going to hurt you because a lot of times you can't use them. But again, you can also feed it like this. And the more TIG welding you do, the better you're going to get at this. Honestly, what you need to do is get to a point where on a flat plate you can do some pretty decent long welds, and then just keep welding, and over time your brain will just naturally help you. This is one of many variables with TIG welding that you need to control that is more or less automatic with the other processes. And that's why people struggle so much, is because this, you have to practice enough to get good, just like you have to practice to get the arc gap really under control and your travel speed, etc. You get the picture. Now, since I mentioned gloves, let's go over and look at these real quick. So glove wise, this does matter. If you don't have a thin glove that you can feel the rod and hold the TIG torch properly, your ability to weld is going to be lessened. And I say that somewhat tongue-in-cheek because I could TIG weld with stick welding gloves just fine, but I have a lot more experience than you likely do. So at the start, I really highly recommend getting a thinner pair of TIG gloves because it will help you build that muscle memory of feeding the rod. Now, my personal two favorite gloves are the deerskin split. This is a Tillman. It's a 25BXL, and then the 24C2XL. Now this is 2XL, this is XL. I generally wear a 2XL glove. I couldn't find these in a 2XL at the local welding store, and these fit okay, but what happens is when they get hot and shrink, that's going to be far too tight. This is a little bit more room, I guess. But these are my absolute favorite gloves, and I'm no shill for any company. I've never taken any free products, and I don't get sponsored on this. I turn that crap down. I'm telling you, this is something you want to invest in. Get one of these. Now, if these are too expensive for you or not available, the Vulcan gloves at Harbor Freight are actually pretty decent for $15. I like them. I buy them pretty often. The only downside to these is whatever leather they're made out of, I don't know if you can see that, but when the fingers get hot, they shrink a lot. And you actually want a fairly wide finger, and I'll show you here. These things fit me pretty much perfect, but you see how much room is in that finger? It might feel a little goofy at first, but as this gets hot and shrinks, it's not going to get tight on your finger. These things, as you can see, and I'm going to put it on, this is so tight to my hand now, I can't even get my finger all the way in. And now that's how you get burned, with no air gap in here. Anytime this leather is hot, your finger is as well. So unless you want some real gnarly looking mitts, I would highly recommend getting a glove that's actually a little bit bigger for your fingers than smaller. And like I said, these are my preferred ones. They sell for somewhere between $20 and $30 a pair. And that's a little pricey because, again, keep in mind, guys, these things are meant for TIG welding. They're not meant to be doing stick welding or grinding with. You do a bunch of grinding with it, and then you wind up with holes in the fingers, which, I don't know, somehow these don't have it, but these do not last very long if you're doing things other than TIG welding with them. So wear them while you're TIGging, and then that's it if you want to be economical about it. All right, let's look at some filler rod angles. As a stand-in for our TIG tungsten, I have this 6010 rod, but we're going to look at a lot of different ways to feed the filler. So if this is your TIG tungsten, this arc gap is obviously grossly exaggerated. A lot of people try and just feed it straight in line with the direction that you're welding. And that's perfectly fine. That's what I strive to do, and you should as well. But you're going to find certain times where you might actually have to angle your rod like this. Like, let's use this as an example. If this was a fillet weld, and imagine this is a plate that's up, well, maybe you can't access this in order to feed it, and you have to feed it like this. That is totally acceptable. The risk you run when you run an angle like this is it's very easy for your TIG tungsten to come too far forward, and now you just dip the tungsten right into the rod. And that's why doing weird angles like this, although it's doable, you're going to want to have higher skill before you start relying on being able to do this. And by higher skill, I simply mean you've done it enough to build the muscle memory to be able to do it without dipping your tungsten. So anyways, back to the simple flat plate. It's totally fine to go straight in. Generally speaking, you don't want your rod angle, and I'll demonstrate it here. Your filler rod angle should be about what your tungsten is. So if your tungsten has a slight push forward like you should be, you want the rod to come in and more or less be at 90 degrees. You can be down a little bit, you can be up a little bit. Where you run into trouble is if you're too far of an angle forward and your rod is more or less flat. You see how wide that angle is there? It's more or less like this. That probably looks better to you. You're going to end up melting this filler rod back over here because the arc will turn into a much longer cone and it's going to spread out forward, and that heat's going to melt your filler rod. So that's no good. So you want to try and maintain a 90-degree angle plus or minus quite a bit, and you're going to find out in a hurry what's going to work and what's not. Speaking of filler rods, one of the things I didn't understand when I was learning to TIG weld is the importance of picking the right filler rod. Now, when I was in school, they basically gave me 3/32 rod and said weld stuff. Well, the problem with that is 3/32 rods for steel takes a lot of amperage. You need to be well above 120 amps for just doing a bead on plate to get acceptable results with that, especially on a fillet weld. So I was basically running far too cold. Now, in most cases, 1/16 filler, which is what I have here, would be my go-to filler. That would be for, I don't know, steel as thick as this, so somewhere around 16 gauge up to about 1/4 inch. Now, if I really need to get the job done fast on quarter, I would definitely use 3/32 rather than 1/16, but the 1/16 will take care of most stuff you would want to do, especially in the low production, high quality welds, if that's what you're aiming for. Now, there's a lot of other choices that are smaller. Here I have 035 wire, so it's basically the same as MIG wire, just in a straight piece of wire. 035 is tremendously helpful on very thin material, like auto body thickness. I much rather use on say 18 and 20 gauge or thinner, much rather use 035 to weld it. You can deposit smaller welds, it melts off better, it's just far easier. Now the downside is if you use too small of a wire for what you're welding, it's just going to melt off and ball up on the wire, and then it's going to be very difficult to weld with. The higher the skill you have, the more leeway you have in what rod you can use. If you find that when you're feeding the filler in, that the molten pool more or less disappears or it humps up every time you try and dab, you're probably using too big of a filler or not enough amperage. So guess what? Increase the amperage, try again. If that doesn't work, downsize your filler rod. Like I said, the 1/16, as far as an amperage rating goes, probably about 40, 60 amps up to about 140, 50 amps. It works just fine. Above that or below that, you want to use bigger or smaller diameter fillers. Now keep in mind, guys, this is advice for steel, stainless, Inconel, titanium, all of those. With aluminum, whatever your normal rod size that you use, you want to go up one. So like aluminum, I almost never use 1/16. I use 3/32. So if you're planning on doing aluminum, and I'll have videos on that on its own later, you want to use bigger rods for that. But for steel, what I told you here will hold true. So you thought you'd get out of book learning. Well, here is some. Let's get through this quick. Here's your TIG tungsten, here's your molten pool, here's your filler rod. The angle this filler rod is coming in is a little bit off, and you would, in real life, your arc cone would come out pretty wide and it'd nip this, but that's all right. What I want to talk about is where to add the filler rod. Your arc cone will more or less be something like this, okay, with this angle. If you add your filler rod back over here, you're going to end up dipping it between the tip of the tungsten and the molten pool. It's going to happen. What you should be aiming for where your filler metal is right here at the leading edge. When I say the leading edge in any video, the leading edge of the molten pool, this is the leading edge. And what you're going to find, and I'll draw like I'm welding this so we have metal deposition, when you add filler, the molten pool rises. One of the reasons why when you're inexperienced you dip the tungsten so much is because you're holding that arc gap to the plate, right? Well, as you add filler material, your weld rises off the plate directly into your tungsten. So one of the things you have to learn and master when adding filler material is you have to hold a slightly longer gap. And guys, I'm not joking when I say this. You're talking like minuscule, like half a millimeter more, or about a 64th or a 32nd of an inch. Very little bit do you need to increase the arc gap. Guys that I've trained before, what I notice is I tell them that and don't give them like a scale of how little it is, and they end up lengthening the arc like an eighth of an inch while they're adding filler, and now your arc cone is all out of control and you have your amperage is all off, like etc. You get the picture. So as you add filler, as you push this rod in, a slightly longer arc gap as the puddle rises. Now I personally, at the skill level that I'm at, I don't really raise it much except on aluminum. On steel, I just hold a slightly longer arc gap, assuming I'm adding filler. Now, again, if you've done a lot of fusion welds and held that nice tight arc, guess what? A fusion weld, you can hold it almost on the plate with a non-existent arc gap and make it work, but as you add filler, it's going to be dip city, where you're going to contaminate that tungsten. So again, you have to hold a slightly longer arc as that puddle rises. A couple other important things to keep in mind here. When you're adding your filler rod into the molten puddle, if you notice that it's balling up, so it's balling up or it's just drooping and falling off before you even get to the molten puddle, it amounts to one of two things. One, your arc gap is too long, that's the most common, or two, you're running too much amperage for the wire diameter. If your arc gap is too long or your angle is off, you're gonna melt the tip of that rod off like it's butter. So you have to keep that tight arc and you have to keep the tungsten angle reasonable. And if your amperage is above 150, 60 amps and you're welding with like 035 wire, well, of course it's going to melt off because the arc cone area is so hot that it can't even enter that area without melting. The other thing that kind of ties this all together, when I say dabbing at the leading edge, you want the rod tip to touch that. I see a lot of guys, they'll bring that rod in somewhere up here, wait for it to pop off. You typically get a tick from the rod. You'll hear it. It goes like tick as the rod melts off and then dips itself in there, that little molten ball. You want to touch it here. You don't want to bring it in, let it melt off and back off. The other thing you don't want to do is what I call lay wire. And that's where your wire, here's your wire, here's your plate, and here's your molten pool and your TIG tungsten, right? Where you just sit there, lay the wire on the plate and weld right over it. Now, there's a time and a place to do that, and it can get you out of a bind on really thin material, and you can use pulse to make pretty welds. I get all of that. As a beginner, you don't need to be concerning yourself with lay wire. And the reason I say that is you can actually get a lack of fusion with lay wire. So on a fillet weld, if you just lay that sewer pipe, whatever rod in there and then come in with the heat, what can happen is you get zero root fusion. It more or less just, the weld will do this. It will bridge over the root and it can produce an extremely weak weld. You don't want that. To do lay wire effectively, you must run very high amperage. It's a must. You can't use low amperage and expect good results. It's entirely possible the weld will look decent to you, but the internals will be junk. And that's why I don't care what process you weld with, you need to test your own stuff with a cut and etch to see what's going on. You can't guess with this stuff. As far as how far to pull the rod out of the molten puddle, that's something that gets commonly asked, and here's my thought on it. If your molten puddle is right here, and now this isn't drawn to scale, and you dab the rod in, pull it back just enough to see the base material in front of it and no more. If you're pulling it back a 1/4 inch or 5-6 mil back and then trying to push it forward, that's going to cause trouble. Pull it back enough to where you can see that base material. That's it. All right. I think you understand enough about all this stuff. Let's go and do some actual welds. To start things off, we're going to go with a straight in rod angle that's pretty low and a forward leading tungsten angle, which is what you should try and maintain, so the ideal circumstances. I slowed this video down about 20%, so it's not real time, but let's watch and see what happens. I'll comment as we go. When I start the arc, if I have the foot pedal to control it, I'll slowly ramp up amperage till the puddle is the size I want. As far as how big the puddle needs to be, well, it really depends on what filler rod and how thick a material, but somewhere around 2 to 3 times what the filler rod is what you should be aiming for on material thinner than about 4 or 5 millimeter. Now, as you can see, I'm dipping that filler in the leading edge of the puddle. I am not anywhere near where that tungsten is. If you run too low of amperage where the puddle's very close to the tungsten, it's going to be very hard to add filler without dipping it. I'm running about 120 amps here, and you can see I have plenty of room to dab that filler without dipping the tungsten into the puddle that rises up. Now, I'm holding a long enough arc to where I'm not lengthening the arc gap up in order to accommodate for the puddle. I'm more or less just cruising at the same distance from the plate. And again, this comes from experience to know where I need to be, but you may find it difficult to do this at first without having too long of an arc, because you have to be very consistent on feeding the puddle, because if it drops out, you're going to long arc it. Now let's look at what it looks like when you run too long of an arc gap. And it's very common for beginners to run too long of an arc gap because it's easier to see what you're doing because there's more light. But when you look at what's going on, that's about twice the gap you would normally want, and you can watch the filler material on the end of that rod start balling up before it even gets close. And that heat source is so basically not concentrated, it's not focused, so it's actually harder to weld with a longer arc gap than what it is with a close arc gap, the proper arc gap. So you actually need to run more amperage with a long arc gap to get it to work. Now, I'm still mostly hitting the leading edge of the puddle with the rod, but a couple times I hit further back in the more or less the middle of the puddle, and if you were to do that with a tight arc gap, you would dip your tungsten into the rod. I can't stress how important it is to hold a tighter arc than what you see here. If you want to have any kind of decent TIG welds, you're going to have to. And I know it sucks because you have less light output to work with and you're not going to be able to see as good. And that's one of those things where if your eyesight isn't as good as it should be, you're going to need to go to an eye doctor and get glasses or use cheater lenses, something, because you guys got to remember what you're seeing here is magnified hugely over real life. That puddle is only about 3/16 of an inch or somewhere around 2.5, 3 millimeter in that ballpark, so not very big, and this is tremendously magnified. Now on this one, I'm going to hold a little bit longer than what I would normally do for an arc gap, but everything's still going to work okay. And again, I'm hitting that leading edge of the puddle. Now it's difficult to tell how much rod I'm actually feeding in at this point. It's not very much. So as I progress forward, I'm only feeding in maybe a millimeter a rod, or about 1/16, so a millimeter, millimeter and a half. I'm not feeding a massive amount of rod in because that puddle isn't coming up very high. Keep in mind, if I was welding an actual joint like a fillet weld or a lap weld on thicker material, I would have to push a lot more rod in than what you're seeing. For a simple bead-on plate where the goal is to get it above the plate with some penetration out the backside, that's if it's thin, you don't need to add a huge amount of filler. Now let's look at all of these in real time and watch how fast it goes. This is the ideal weld here. This is far too long of an arc. This is overall okay as well. A little bit too long of an arc, but it's okay. Now let's look at a few more welds. Here we have one where everything's going to kind of go all right. This is at about 20% speed. So again, you start the arc, you wait for that puddle to get to the approximate size of what it should be, which again, use your filler rod as kind of a gauge. If you're using 1/16 or 1.5 mil filler rod, you don't want a huge massive puddle. Now you can see how as I'm adding filler, the puddle is staying slightly above the plate. Now this is thinner material here. I'm only at about 60, 70 amps. The previous material was far thicker than this. This is about maybe 1/16 thick, so pretty thin. I'm adding a little bit of filler to bring the puddle up. My arc gap is staying very consistent, and you can tell it's consistent. Well, for one, because the tungsten's more or less staying the same distance away from the plate, but you can also tell because the light output isn't changing much. If you see a lot of light output change as you're welding, that's a great indication that you're too inconsistent on your arc gap. You don't want that. Here, my arc is getting a little bit longer. You can tell because the light output changed, but again, we're looking at such a small little weld here that any little change shows up far bigger in this than what it would to you in person. Nobody has vision that can see a weld this big, so the details here are kind of more prevalent than what you would see in real life, especially if your vision isn't that good. Again, everything on this weld seemed to go exactly to plan. I don't see anything wrong. Interesting note, that blue halo that you kind of see, this plate was cleaned decently, but not as good as it should be, and some of that is likely surface contamination burning off. Now let's look at one with too long of an arc. So I start with a little bit long of an arc, and my puddle isn't even established, and I start cramming filler rod in there. You want to give the puddle time before you go cramming that rod in. Now this arc is slightly longer than the previous one, and the other thing I'm doing is I'm moving simply too fast forward. You can watch how that puddle is necked up. It's not widening out. It's more or less sitting like a bead of caulk. It's humping up as I add filler. Anytime your weld goes from a decent width to like very neck down, that's because you're moving too fast and you need to slow down. Now this is shot in slow-mo, so you can really see how much I must be moving for speed versus the previous weld. Along with that longer arc, and things just aren't going well. The rod starts melting off before it even gets to the weld pool, and then you get like this weird droplets on the side of the weld where it's not fused. Now on this one, we're gonna more or less go too slow. You can see that molten puddle is increasing in diameter pretty significantly, and I am not gonna be moving forward very fast at all. What you're gonna notice is the puddle will tend to destabilize, especially on thin material, And not only will it start getting a little bit wonky on you, but the bead itself, especially on thin material, will flatten completely out. And that's because it's melting through and the bottom is sagging out due to gravity. But I'm just barely adding filler in here, barely moving. This you don't want to see. Now, if this was 1/4 inch or 5/6 mil plate, you could get away with this. But when you go real slow and you don't add much filler, you're going to produce undercut with TIG. Now, undercut with TIG is generally pretty easy to fix. You can always do another weld over it to clean it up. It's far harder with like stick, where undercut can trap slag and then you can't get that out of there. And then when you weld it over it, it creates a slag inclusion. So, you know, TIG has a lot of benefits to it as far as fixing undercut, but you don't want it anyways. And again, this puddle is just far too hot due to the heat input. So the best thing when you're trying to train yourself to run beads, run the same speed start to finish. If you look at the weld when you're done and you're like, my God, that's real wide and doesn't look good, then speed up a little bit faster for the next one. When you try and make a ton of adjustments during every weld, you're going to have a hard time figuring out what the actual problem is. Focus on going one speed and then base what you're going to change on your next weld on what you see that weld looks like. Now let's look at what happens when you add way too much filler. So again, wait for my puddle to appear, and then I just start pumping that sucker full of filler rod. I'm adding at least 1/8, so probably like 3mm rod each push. Now you notice the light output changed, and that's because the molten pool rose up closer to the tungsten. And I just keep pushing more and more filler rod in it. It destabilizes the puddle, and I have to lengthen my arc gap so the tungsten doesn't dip into it. And this is where most of your dips are going to be. Because you're adding so much filler into there, you have to run a longer arc, and without training your brain to automatically do that, it's going to be dip city. This is not what you want to see. Now, sometimes you may push a ton of filler in on a joint, but when you're practicing, you know, this is far too much for just a bead on plate. Let's look at all of these previous welds in real time now. Here's a weld where everything goes fine. Here's where I move far too fast. Here is moving far too slow. And finally, here is adding way too much filler. Let's look at a few welds where I'm going to use different filler angles and different filler diameters. So up first we have 1/16 filler or 1.6mm rod, and I'm going to move far too fast for this. So I got my arc established, the puddle isn't even barely the size that I would like, and I start moving and I start cramming rod in there, a very little bit of rod, just basically tapping it. And you can see that the leading edge of that puddle is not uniform. So it doesn't have a nice round overall profile curve to the front. I'm moving too fast, and realistically, if I ran more amperage at this travel speed, it would probably work better. but nothing about this is good other than I am holding a decently tight arc and I'm consistently holding that, but this just doesn't look good. The finished weld turned out okay, but this is not ideal. Now in this next weld, I'm running a little bit more amperage. So the previous one was probably like 50 amps or so. This one's about 65, 70. Still using the 1.6, aka 1/16 filler, and I'm shooting it in at an angle, as you can see from the direction of travel. Now that leading edge of that puddle, as you can see, is more or less a crisp circle, and that's what you want to see. When that puddle is changing shapes, you're probably running too low of amperage or you're moving too fast. And this is exactly what you want to see. The bead is wetting out really nicely and it's flattening out to a certain extent, but everything's kind of just going a lot better in this. And it's a direct result of improving the travel speed a little bit and running a little bit more amperage than the previous one. In a lot of cases with TIG, you can simply slow down to get things to wet out better, but beyond a certain point, if you're not running enough amperage, that's not going to work, and you can also lose root fusion if you're doing a root pass on something. Now in this guy, I'm going to use a straight in rod angle, so I'm not going to come off from the side and just show you that. The molten puddle is going to function and look just the same, and we got a decently round front leading edge. And you can see I'm not dabbing it way back in the middle of the puddle. I'm catching that front edge. Now, if you don't run enough amperage and you do this, the rod will stick to the plate. And that's something you got to get used to when you're running a kind of too big of a rod for your amperage, which is somewhat common. Because remember, we can't make every rod amperage combo perfect. So if that rod sticks to the leading edge, just kind of run it over with the TIG torch and remelt it, and maybe consider running more foot pedal or a higher amperage setting. But this is running pretty good and the rod isn't sticking because we're running enough amperage. The arc gap's getting a little long here, but again, overall not bad. Now for this guy, I dropped down in filler diameter, and I apologize, it's kind of out of the screen right now. It'll come into focus here shortly. I went to 0.35 wire, so very small diameter, and there's a couple things you want to pay attention to. One, the puddle's a little bit smaller. Two, as I'm pushing that rod in, I have to feed more of it to make a weld. I'm also holding a tighter arc gap because guess what? I'm not producing that tall of a weld pool because I can't push that much filler into there. And you can see how fast that melts off. It's not even quite in the puddle and it's already melting down to the plate. You can see where it almost like sticks to the plate a few times. Running small diameter filler is a great option for really thin material because you got to remember, the more filler you try and melt and add, the more amperage you need to run. So on super thin material, if you're running 1/16 filler, you're going to have all sorts of problems melting and blowing holes with it. Overall, again, this is running really good, and I'm holding a tighter arc gap. Whatever your filler rod diameter is, that's the arc gap you want to generally hold. Well, now let's look at all of these in real time and then move on. Random quick comment here. I know it looks like that filler rod is dancing all over the place and it's moving like a 1/4 inch or 5-6 millimeter. It's not. This is so zoomed in that the difference you're actually seeing is less than a millimeter. So under 1/16 of an inch, it just looks like a lot because we're so zoomed in. Here are the welds that you just saw me do on camera. You can see how heat soaked that is due to how many welds I did and how thin that material is. Now the first weld I did on the left there is the only one that's above the plate by any amount, and that's because it was cold. The rest of them are sunk in or more or less flat. Now let's do a look at filler metal adding, and this is going to be a quick 2 bead experiment. I'm going to feed it more or less straight in. Now, don't mind the sparks. The surface of this isn't perfectly clean. But you can see I'm just dabbing it in there, moving along. Pretty slow travel speed, and that's TIG in general. But a direct inline filler addition works just fine to make a weld. There's no issue doing this, and it's the preferred method. Now let's look at angling it to where I'm coming in at a weird angle, and you're going to see that both methods work and both produce welds that are acceptable, especially on a flat plate. The real world isn't a perfect situation where you can always do the book way, but this works just fine, and you'll see once I cut the arc out that both of them look very much the same. One's a little bit straighter though. Oh well. Well, let's move on. So, what did we learn today? Well, we learned that there's more than one way to skin a cat per se on how to add filler and the angles and all of that. Now, we didn't really cover much actual welding of joints like fillet welds, lap welds, etc. That's going to be in the next videos, but you really need to understand the basics of what I covered here first. Now, as far as what to practice to really get good, it's in your best interest to take a plate like this, and this is somewhere between 5 and 6 millimeters, somewhere around 1/4 inch, and run bead after bead with fusion welds until it's full, grind it down flat, do it again, grind it down. And once you can get 100% solid fusion welds that are equal start to finish and width and everything, and you've done, I don't know, a couple hundred, then look at adding filler like you saw in this video. And again, expect to dip your tungsten a significant amount because you're learning a new skill of adding filler and maintaining an arc gap to a taller molten pool. So you will dip it a lot. Realistically, you need to master simple, flat beads on plate. If you cannot do a whole plate or even this whole thing with 4 to 5 inch long minimum welds that are super straight and very consistent, everything else with TIG is going to be much harder. I know it sounds lame to sit down on a plate even this big and all night long for multiple nights a week just run 5-inch beads until you get so sick of it that you want to do anything. You rather put horseradish in your eyes, okay? That's when you know you have a decent handle of it, what you're doing, and you can move on to actually doing welding joints like on fillet welds, lap welds, outside corner joints, etc. Because here's the deal, guys. To get good at TIG and to be functionally good and be able to weld on any number of things, you're going to have to master the basics. So would you rather weld on something like this until you mastered the basics, or spend a lot more money burning up plates and fillet welds and lap welds and all of that, wasting a ton of material to get to that point? From an economics standpoint, it makes sense to stick with plates like this and just get all of the hard stuff out of the way on it. And then once you go to actual welds, it'll be a lot easier. So anyways, with that said, thanks for sticking around for this video. I hope you learned something. Until next time.